Okay, I think we're at 9:30. Oh, we have one person in the live stream right now, according to this thing. Maybe we'll get some more. Um, Two things today. One of them is just kind of a discussion of being able to print parts that are more functional. I call it stronger parts. And then another is simple multicolor parts. So I've already shown, or have I? Maybe I haven't shown. Um, I've been printing a couple of little things that are multicolor, but these are like multi-piece models. So they're just, multiple pieces that you can print and put together. These were all printed on our Ender 3 with no tuning. So other than the bed, I've leveled, leveled the bed so that it is has the best chance of the part sticking down. I haven't had any print failures. Oh, I had one, but it was my fault. I was printing PETG, which this brown stuff is, and then I switched to the green, which is PLA, and in my slicer, I did not switch the material, so it was printing the PLA as if it were PETG, and I noticed that it was really stringy. It was printing, but it was not the quality I thought it should be when it was printing the green PLA. And then I looked over at the screen, and it was at 240 degrees Celsius or something like that, a really high number for PLA. And then I remembered that, oh, I must have sliced that like it was PETG. So it is a good idea to, when you slice something, preview it to make sure that the file that it has sliced looks like what you expect it to look like. But then to take a few minutes to watch the first layer go down, and if something's not looking right, try to see, is there something I forgot. In that case, it was that I was printing PLA as if it were PETG, and it's just too hot for it. It would print, but it was very very gooey. I think I threw the part away. It was only like the first layer of this thing, so the very bottom of it was just didn't look right, and it kind of smelled weird too. And the fact was that I was printing way too hot. So that's just a thing to remember. But this is one way you could do multicolor. Just have parts that snap together or fit together, and that works pretty well. So these, again, I haven't tuned this thing at all. We're gonna tune it a little bit. We're gonna change out some of the parts. We're gonna change out the hot end. We're gonna change out the feeder, kind of off your back of your screen here. We'll put a different bed surface on. We'll do little upgrades just to show you what they do, but it's printing actually really well already. So $100 printer, well, if you find it on sale, like I think the default price for these is maybe $160 or $170, but if you look around, you can find the base model Ender 3s for $99. All right, so that's one way you can do multicolor, but we're going to do a different method today on how you can do a simple multicolor part. So let's do that first. Then while it's going, we can work on the idea of printing stronger functional parts, because sometimes you don't want just something that sits around, but you want something that actually does something. So let's look at a way that with a regular printer, so only one print head, no multi-material feeder system or anything like that, just one regular printer, you can get multicolor parts. So I'm going to go, and let's go over here to the web page. So Canvas, I put in the YouTube description, I put most of this, so it's out of order, and here it's talking about stronger parts first, but here is some G code that we're going to actually use. G code, edit the actual file that gets sent to the printer. We're going to edit that, and then I've got pretty step-by-step with all open source, well, not open source necessarily, but all free software, so you don't have to have any special software either. You can, but if you don't, then as long as you can get online, then you can do this process with online free content. All right, so step one, we want to find an image that we want to convert. So our idea is we're going to print one color for a while, and then we're going to change out the color and print on top of that color with a different color. And you can keep doing that as many times as you want to. We're just going to do 2 to prove how it works. but you could stack as different colors as many as you had if you wanted to. So this isn't going to mix the colors together in any way. There'll be one layer, or well, there'll be some layers of one color, and then on top of that there'll be some layers of another color. So we're gonna do, since we're in Louisiana, we're gonna do the Saints logo. So something like this. Now this, let's see, let's get a bigger picture. This is a 3-color. I've got no color in the background. I've got a black, a white, and a gold. We're just going to do 2 colors. Actually, I don't even have any of these colors, so ours is going to look a little bit weird because it's going to be whatever colors we decide to print it in. But we need this. So you find the picture that you want to layer these colors on. So I will just copy this image. I think, well, no, let's copy it, see if that works. All right, we'll leave it open in case we need to save it. Oh, that's for later. All right, so open the image that we just found in photop.com. So this is a online, it's ad supported. So off the side of the screen are a bunch of ads that are playing on my screen. They're just not on the stream. But this is an online Photoshop supplement, but replacement, sort of. It doesn't do everything Photoshop does, but it does a lot of things that you probably need. If you don't own Photoshop, you probably don't need all those kind of things that it does, and this does everything you want. I don't know what, like if you create a file on here, I don't know where that file actually goes. Do they keep access to that file for themselves or what? I don't know. But we don't need to do a whole lot with this. So we're just going to make a new project, and we will just create, it doesn't even matter. We're just going to blank canvas, and then we are going to paste in our logo. So since I had copied that logo before, the canvas it created was just the right size. So now I've got the logo here. It's just a, I don't know, bitmap. Well, actually, it's nothing yet. I haven't saved it at all. It's going to save it as a PSD type thing, but we're not going to do that. All right. Step 3. So in Photop, we want to image vectorize bitmap. Okay. So again, all these instructions are in the YouTube description too. That I just had to simplify them a little bit because I can't use all the same characters, and there's a character limit, all that kind of stuff. So image, there's image, and there's vectorized bitmap. Okay. So here's my original file over on the left, and here's the vector version of it on the right. That looks pretty good to me. You can control how many colors it uses. Now this is only 3, but it's got up to 20 here, but I can scroll that up and down if I want to simplify or get more colors in there. But this is turned it into a vector. So I don't know if you can see on the video, but I can see on my screen, like this side is jaggedy, like the edges are jaggedy, and on here they're smooth. So the left side is a collection of pixels, and what color is every pixel. On the right side is a bunch of equations that control the shapes and then the colors of what those shapes are. And so it's a different process, and I need that vector process. This looks good, so I'm going to click OK. I didn't change any of the defaults there. I just used them. You can modify them if you think you want to. All right, so I have done that. Now I'm going to File, Export as SVG. Okay. So File, Export as SVG is the vector format. So there we go. I'm going to make it a little bit smaller because of the next step. I don't want it to be gigantic. I don't want to try and print a 2-foot size logo. So I'm going to make it smaller. These are in pixels. You could change it to different units here. I'll leave it at pixels. And I know that I'm limited by 1,000 pixels on the other one. So I'm going to go under that and say 800 here. It should automatically, adjusted the other one. This little chain says that it's going to lock the aspect ratio to whatever it was. It's not going to stretch it out one way or the other. So I just picked the larger of these and made it less than 1,000. So that should work. I will save. All right, it put it in my downloads over here, new project 1. Okay. I could have named it something other than new project 1. Now we're going to, so we're done with Photo P. We can close that. I'll probably leave it open in case we need to go back. Now I'm going to go to Tinkercad. This one is, so the Photo P, I don't even know if you need to log into that. I think you can and save things in their cloud, but I don't ever do that. I just do what I need to do, save the document, and then I'm done with it. But with Tinkercad, tinkercad.com, actually you go over here. Here's the beginning. So you can see I've already tested it out over there. So tinkercad.com, you do have to have an account, but it's free. So it is also an Autodesk account. So if you have done any Fusion 360 or any of their other products, then it's the same account. So you do have to create a free account here on Tinkercad. So I will go to create a 3D design. Oh, that's off. That's under. So it's under my head. So I'm over here. It's right up above there on the picture. It's under my head. But there's a plus create blue button, and then you click on that and you want 3D design. And that will take us over here. So this is, you know, I like Tinkercad. So a little aside on Tinkercad, you don't have to download anything. It just runs in your browser. It's pretty fast. It's not CAD like Autodesk, Fusion type stuff, or it's not like SolidWorks. It's not that kind of CAD or Onshape, where you've got a parametric model and you've got a history tree of all the things you've done. It's not like that at all. But it can do specific dimensions. You can tell it you want, you know, I'm down, let's see, I'm off the screen. Let's make this, let's see, well, off the bottom of the screen, I can change different unit systems. I'm going to go to metric. There we go. Millimeters. Bricks are like Lego bricks. You can actually build in Lego brick units. So I've changed it over to metric just because the slicer and everything in the printer is going to operate on metric units. So might as well be in metric units when I do this step. Here's a little thing I've printed. So let's see, go over here. So I made this little, you know, you can make stuff like this. It's a little card holder, so you could put some little card in there. All in Tinkercad, super fast. It works a different way from what you're used to. If you're used to more of the CAD modeling, like SolidWorks and programs like that, this one more is intuitive. So if you haven't done any CAD modeling, it's actually pretty easy to get started with. Let's see, I think we're over here. Yeah. So the idea with it, and I do need to make this smaller so that you can actually see some of the buttons. So that looks okay. There we go. So you need to be able to see this stuff on the right side over here. And maybe I can make it a little bigger so it takes up more of the screen here. Don't want to cover up. There we go. We'll just leave that black area. That's fine. So the idea is you can just put blocks in here, and you can, you know, move them around, make them welded together or whatever. So you can do a lot of like designing from scratch. That's what I did with the little card holder. That's not what we're doing right now, but we just need Tinkercad or some program like it. But the instructions I have laid out use Tinkercad because it is free and it's online. You don't have to download anything. So where were we at? Open Tinkercad. All right. We're going to create button, select 3D design. We did that. All right. So now we're in the Tinkercad workspace. We're going to import and select that SVG we just saved. So that's import, choose a file. I called it new project 1, very creative name. Now, actually, Tinkercad is going to give it some random name. We'll look at that in a second. So there's our SVG. You can see the .svg on the end of it. Oh, it's larger. So even though I reduced it, it's still larger. So it looks like we need to reduce it by 40-something%, because it says that the dimension has to be 1,000. Oh, I was thinking pixels, but it's actually 1,000 millimeters in any direction. So we'll do 40%, and now it's okay. So I'm looking in the very center here. Those dimensions, each of them have to be less than 1,000. So we'll actually, that's still kind of large. Let's actually go smaller than that, 20%. Okay, import. So it might take a little second for it to import this SVG, but what it's going to do, well, yeah, it's gigantic, isn't it? So let's scale that down some more. Actually, let's see, we can scale it in different directions, but I want to scale it uniformly, so I'm going to hold down the shift key to get it a reasonable size. Let's put it in the middle here. So it's already turned it into some kind of thickness. I can control that thickness over here, and I can control the quality. The quality is basically how many line segments does it have. It looks pretty nice already, and the height says 10. I'm thinking that might be 10 millimeters, so that's kind of thick. Let's change that to something so it doesn't take quite, we can scale it in our slicer too, but let's see, it's currently, you can see I'm hovering over one of these dots, and you can see the dimension pop up. That's 81 millimeters, so that's pretty big. I want this to be maybe 40 millimeters, so let's scale it down some more. Oh, that went to 26. Let's 30, 40, there's 40. Okay, so that looks reasonable. It won't take forever to print. This is not what we want to print though. All right, so let's go to our next step. Oh yeah, you may have to scale it to make it more reasonable. So we're going to copy it, and copy in here means duplicate. So Control D is duplicate. So I select it, it's already selected. You can see there's not selected, there's selected. Control D. Okay, now it's selected. Well, it's selected and duplicated. There's actually two of them there. You can see there are two of them there. I just moved it over and then Control Z to undo what I just did. Okay, change the fill mode to silhouette. So one of these is selected, the one I just moved. I'm going to change the fill mode to silhouette. So up here in the, when I select one of these, you can kind of, it doesn't matter which one because they're exact copies of each other right now. So I'm going to change fill mode to silhouette. Might take it a second to operate. All right, so now I've got like a solid piece here. So what's happened, if I see, I've got one that's basically just the very outline solidly filled. So move it back. And the other one still has the shapes in it. Now I'm going to reduce the height of the silhouette so that it drops down. Oh wait, wrong button. All right, there we go. So to reduce the height, you've got this little button right here. So right now it is, oh wow, we've only got it 1 millimeter thick. So we might have to scale some things, that's fine. 0.99. That doesn't, it looks like it's thicker than 1 millimeter, but I guess these grids are, each one of those is 1 millimeter. So we probably do need to make it a little thicker to begin with. Let's select everything. So Control A, and I'm going to change, so Control A is select all. I want to change the height to something that's reasonable for me to print. I think 3 millimeters is probably good. So let's change it to 3. So there we go. Okay. Now I'm going to select one of these. Actually, I want the solid one, right? So is that the solid one? Yes. And I'm going to make it shorter. So maybe 1.5 millimeters. Let's see what that looks like. Okay. That looks a little extreme to me, but we can scale it differently in our slicer software if we want to. But now you can see where I've got this lower infill, and then I've got this raised ridges around the edge. Okay, let's go back. Control A to select everything, and then Control G to group. Okay, so Control A selects our two pieces. Control G merges them into one thing. Gave me some errors here with the red lines, but all right, they went away, so it looks fine. Okay, now I've got just one item. Okay, export this as a STL. So over here I've got export. That's where the import button was, where I got this in the first place. There's export. I can send it straight to Autodesk Fusion if I wanted to, but here's the STL. Also, you can select just everything in the design or the selected shape. I only have one shape now, so that is everything in the design. So it downloaded it, and it named it. So here's the name. The way Tinkercad, if you don't tell it to do differently, it gives you some kind of adjective. In my case, it's fantastic, and then some kind of made-up word, Albar. So this thing is fantastic Albar, and you can change it. You can see that it says change name if you click on it. All right, now we have a STL, fantastic Albar. We can bring that into Cura and slice it like we would normally. So let's go to Cura and open. Let's find, there's fantastic Albar right there. All right, so it's kind of small in there. Let's make it slightly bigger than that. Let's scale it. Let's not uniformly scale it. Let's keep the 3 millimeters, but then let's scale X and Y by, I don't know, 150%. That seems reasonable. That's okay. All right. Now let's see what I'm going to print this in PLA. So let's make sure I'm on PLA. Yes, and I've got a 0.4 millimeter nozzle. Yes. Layer height 0.2. That's okay. It would be good to, when you're designing the thicknesses of everything, to make sure that everything is some multiple of your layer height. I made it. I did 1.5 millimeters thick for the infill part, the lower part here. That's not a multiple of 0.2. Well, yeah, no, it wouldn't work with it. So it'll have to do a partial layer, which means it'll leave off one layer. That's fine. It would have been better to do that at like maybe 2 millimeters so that it's a nice even multiple, but it's okay. We're going to do 2 walls just to have some strength but not overdo it. We will do 3 top layers. That's good. Let's only do 2 bottom layers just to speed it up slightly. We've got our temperatures for build plate and printing for PLA. Relatively conservative print speed. That's not too fast. We do need cooling because we're doing PLA. We don't need any supports. We'll throw the skirt in there just to get the nozzle primed. So we'll slice that. It says 27 minutes. Let's preview it just to make sure I don't have some crazy settings on. Okay, that looks generally good. There's some weirdness like in some of these corners here. You know, it's just printing a single dot in some of the corners. It'll be okay. There's actually a way, maybe we can turn that on. So it'll take longer, but there's actually a way to use the nozzle itself of your printer as kind of like an iron. In fact, the setting is called ironing. And if you enable this, then there are, some settings. I'm going to leave all the defaults. If we slice it now, it'll take longer. So 36 minutes. But what it'll do is you can kind of see these new little skinny lines here. It will rub the nozzle across any top layers. It's going to do that bottom part down there and the top of our ridges, and try to iron them out. Like they're going to flatten them out a little bit. It doesn't take oh well, that's going to take too long for our print though, because I'm going to print this, and that's going to be a little bit long. So I'm not going to turn it on this one. Maybe we'll print this one normally. So we're going to, oh wait, I need to turn it off though. We're going to disable ironing like the default is. And also let's make our layer height a little bit, we can go up to 0.3. So in general, if you're not sure what layer heights you can do, in general, you can print as thin as 25% of your nozzle diameter and as thick as 75% of your nozzle diameter. Those are not rule. You can break those rules, but if you don't know what you're doing and you just are kind of wanting to know the limits without some special settings, that's kind of it. 25% up to 75% of your nozzle diameter. My nozzle diameter is 0.4, so I can go down to 25% of 0.4 or up to 75% of 0.4. So 0.3 is okay. And theoretically I could go down to 0.1, but that's going to be a lot of layers and it's going to take a while, and you got to get better tuning when you get to the extremes. All right, we're at 22 minutes. That should be okay for something we can do here. All right, so we're not done yet though. So over on the, you can see it over on the right here, it's almost off the screen. There we go. Or it's under my picture. So I've got this number 10 over here on the very right hand side. That is that there are 10 layers. Now I can scroll down through the layers and look at them. So the very bottom layer is layer 1, and then what I need to know is when do I want to change the color. So I want 2 to be one color, 3, 4, 5, 6. All right, 6 is where it starts printing the other stuff, the outline things. So I want to print 6 layers and then switch over to the other filament. Now, in extensions over here, there is post-processing modified G-code. That's a default setting in Cura, so you have this. It will let you go in and do pauses and things that layer changes. It doesn't always work. So it depends on a lot of factors of what firmware you're using, and it doesn't always work for me. So we're going to do this a different way. We're not going to modify the G-code here. We're just going to take the STL file, and we're going to save it to disk. So I'm going to save it, let's save it on the desktop. And there it is, my printer, Fantastic Albar G-code. Save. All right. Now, I'm in Cura, and I'm looking at layer 6, but I started counting at layer 1, so that's important. Let's go back to our instructions. So we need to open, oops, that's actually not the STL. That's we need to open the G-code in Notepad. So the G-code we just saved, I need to correct that. In Notepad or similar, basically not a word processor. So if we open it in like Microsoft Word, then when we save it, it might accidentally add a lot of header information like the date and author and all this kind of stuff, and that's not G-code. So it can, hopefully your printer just ignores that, but it could mess up the file. So I'm just going to open in plain old Notepad. Actually, that's not true. I'm going to open it in Notepad++. So it's just a fancier version of Notepad. So let's open that file. File, open. It was on the desktop. There it is, Fantastic Albar G-code. This, and it's plain text. So this is the set of commands. You can see why it's named G-code. There's a bunch of G's in here. This is a set of commands that tells the printer how to create whatever it is you just sliced. So it's got some comments up here. Marlin means that I'm using a Marlin firmware. This is the estimated time, how much filament it thinks it's going to use, the layer height that we set, the position of the thing, a whole, how far, it's kind of just some comments. The machine, the printer, doesn't actually use any of these. It starts here. So there's some machine commands telling it to turn on the heaters, get them to get the hot end to a certain temperature. This one is telling get the bed to 50, getting the hot end to 200. There's a couple of things here on. There's home, so it has to home all the axes so it knows where it's at. All right. So all of that content is in there. We want to find the layer where we want to change the color. So we wanted to change it on layer 6, but that's starting from counting at 1. And if you look here, the actual G-code starts at layer 0. So we're off by a layer here. So In this counting system, that would be layer 5. So I want to find layer 5. So I could just scroll through here and try to find it, and that would work, but there are thousands, no, there are 24,000 lines of code here. So I don't want to just scroll. I want to do Control F and look for layer. There's layer 1, 2, 3, 4, 5. So there's layer 5. So this G code that follows it is all the code that would make this layer where we're starting the ridges on top. This is where we want our second color to be. So, whoops, wrong. There we go. I'm going to, before it starts writing that code, this is the first line of the code to make the ridges. I'm going to insert some stuff. Now I have already written here this set of code. So I'm just going to Control C to copy, go back over to my notepad, Control V to paste. Now it's all spaced out. We can, you know, remove the spaces, make it more condensed. And we can close this. All these comments are kind of all over the place. So G91 changes the machine to a relative positioning mode. So instead of telling the print head to go to a specific spot, it tells it to move by a certain amount. Lower bed, so in my printer the bed doesn't move up and down, so that actually raises the nozzle, so that when I move the nozzle out of the way, it's not just sitting on the part I just printed for however long it takes me to change the filament. It's going to be out of the way, or at least it's going to be moved up. Well, absolute positioning mode, so go into specific spots, and I tell it to go home so that you can actually see that one. So G1 X0 Y0, so that tells it to go at speed 1 to X coordinate 0 Y coordinate 0. So that one kind of makes sense. This one says to play a beep sound. Not all printers are going to play a beep sound. This one should, though. So that's just kind of an alert to me that, hey, I'm ready to change filament. This one, I'm going to erase some of this because I don't like it running over the line here. That's just a comment anyway. Everything after the semicolon is a comment. I just didn't want it to go into the next line, but I think I could have just made the window longer. So what this is going to do is M0 is going to pause. So now the print head is over in the corner, 10 millimeters raised up from wherever it was before. And it's going to put load new and click. It's going to put that message on my screen. And that'll give me time to change out the filament, put the new color in, and then click the button on the printer. Then it goes back to relative positioning mode. It's going to extrude a little bit of the new filament, so just to prime it so that it's doesn't have a gap in it. Oh, whoa. Oh, I don't have any comments on that one. All right, so though that is pause, it's pausing again, and it's saying that, hey, have you cleared out is there a ooze under the nozzle or anything like that? You've got it ready and you're ready to print with the new color. It raises the bed back up, which actually lowers the nozzle because my bed doesn't move up and down. And then it goes back to absolute positioning mode, and then it picks up where it left off. So it goes at a certain speed, F2700, that's millimeters per minute, I think. And then it goes and it extrudes some filament. Well, no, that's just the cumulative amount of filament it has extruded up to that point. Here's where it actually goes to the where it left off at. So X coordinate and a Y coordinate with some new amount of filament here. And you can kind of see this is the running total of how much filament it has extruded in the print. So this little part that's outlined with the orange bar, that's our stuff that we inserted to change the filament. So we will save this G code. Actually, let's get our little SD card and put it on there. Okay. So we will save as, and we'll put it on, I guess it's that one. Is that one? No, I think that's, it came up as G, yes. We'll, we'll just use the same name we had before. There it is over, whoops. There it is over there. We will eject this because I like ejecting them instead of just taking them out. It doesn't exist. Keep this file in editor. Sure, we can keep it over there. Okay, and we should be able to close Notepad. Oh, do I want to save that? No, that's fine. Okay, now we're over at our printer. Now I'm noticing, kind of off the screen here, but this, sometimes you leave filament attached to your printer and it will just break. PLA in particular will do this. It gets brittle if it absorbs moisture, and being here, there is a lot of moisture in the air to absorb, and so you might come back to your printer and it's just, snapped in half. I didn't want to print the Saints logo in green anyway, so we'll go over here and we will go to temperature, preheat PLA, and we'll go ahead and preheat it so we can change out. What colors do I have? Well, we're going to do a red and blue Saints logo because that's the colors I have sitting here. This is blue PLA from Hatchbox. I like their stuff because look how nicely wound it is. It's a little dusty. I haven't used it in a while, but it's very nicely wound compared to something like, that, which is Matter Hackers. So, not that the Matter Hackers doesn't work. I use it all the time, but I don't know. You just have a little more confidence when it's wound up very neatly. It'll probably not work now, but at least it looks like it would work. All right, we are heating up. We're at 130, 140. We should probably clean our bed. I haven't printed anything on it in a while, so let's get our IPA out and wipe it down. The bed is heating up too, so it's going to evaporate really quickly, but doesn't look too dirty. But it's really the oils that are on there, and I'm noticing that this paper towel is actually leaving little hairs on there, so I wiped it again. All right, we are at 197. That should be enough to remove this filament. So remember, I like to push in a little bit and then pull it out. There we go. Our blue, I need to find the end of the blue. There it is. So our blue, I'm going to cut it at an angle right now. It's kind of just chopped off flat. So now it's a little sharper. And you usually have to twist it a little to get it to go in the hole there. I'm going to push there. Now we can go back over here. I've got a little bit coming out. I'm going to extrude some just to get rid of some of the green. So that's motion, move axis, extruder. I'm going to extrude by 10 millimeters, and I'm going to do that 1, 2, 3 times. So 30 millimeters, and we'll see if we have blue filament coming out or not. It looks pretty good. I don't see any green. It might be tinted a little bit green at the beginning there, but it looks good now. Okay, so that's that. Now we'll go back to our main menu here, and we will print from TF card our fantastic owl bar, and hopefully when it gets to the end of the blue, it will prompt us to change colors, and somewhere around here. Maybe I've got some other color. Let's see. That will, yeah, here's a red. Now, this one, it looks orange on the camera, but this is red. This is going to give us a little bit of problem. Now it color corrected. One thing is that it's not on a spool. So sometimes maybe you'll trade some filament or you'll get a sample somewhere. This is a sample, I believe. And it just comes like this. That's fine, but it does stand the risk of tangling if it's not on a spool. Let me check really quickly if I have a spool. So somewhere, and I don't see it now. Maybe, oh, there it is right there. All right. So you can save your regular spools, and you know, when they're empty, rewind one. Depending on how much of this there is, that can take a while. But you can also print these little ones that come apart, and then you just like put filament on there. It's not going to be super tight, but it does kind of keep it from tangling quite so bad. So I'm going to do that. Looks like our blue is printing pretty well. So now I've got a spool of red filament that before was loose. You can print with loose rolls of filament, particularly if they're only like that long. That's not very much. But you do run the risk of them tangling up. So if you use a lot of short rolls, then these two-part printable, this is just printed gray filament that I printed this little spool in. I'll see if I can find it, but that's a long time ago, so I don't know where I found it. I'm sure I got it off of Thingiverse, but finding it again, I don't know. We'll look and see. That's pretty helpful. All right, let's see. Thingiverse. Let me see if I can find see if I can find it. There's a bunch of them on here. A lot of these are spool holders. It doesn't have to be this exact one. I'm just looking for a simple one. Let's see what this one looks like. So this one here looks like it would work. It's not the same. It looks like more it snaps together versus screws together. But something like that. You can find these things on Thingiverse anyway. If I find, I like this one that screws together, but you know, if I can find that one somewhere, I'll let you know. But I don't know, the chances of finding it after so many years is probably not that great. Although that kind of looks like it right there. That's similar anyway. So actually, maybe I saved it, and I'll look through my saved files and see if I can find it. All right. So it is currently over here printing away, and it's at Z equals 0.2, so it's on the first layer. So it should print a couple more layers. Well, you know, up to layer 5. Well, counting at 0 up to 5, then it should finish that layer, and then oh, you know what? No, layer 5 is layer 6, which is the first of the other. So first of the other color. So it should be okay. We'll let it go, and we will talk through this other concept while it's printing. So the other thing that I was going to talk about here, and I put an abbreviated version of this in the YouTube description, but I couldn't put all of it. The idea here is that maybe what you want to do is you want to print functional parts, not just stuff that you sit on your desk, but you actually want to use these parts. So I put together, how many? 9. I put together 9 things that you might think about when you are trying to print something functional. So first, well, number 1 is like, just know if this is a thing that you need to print. And I kind of repeated that later on. Not everything has to be printed. It is fine to, if you've got to build a prototype of something, for parts of it to be printed and parts of it to be bought and parts of it to be like hardware type of stuff, nuts and bolts, or so, any combination of those things. So don't get in the trap of thinking you've got to print everything if you're printing something. So that's kind of like the first thing. I see this a lot. We have a prototype in lab where students can just send in items to get printed, and some of the stuff are things that I would have just gone to Lowe's and bought a PVC pipe instead of printing a tube, or something like that. So think about the thing. Is this something that's going to benefit from 3D printing? If it's something you could just buy, it's probably going to be, assuming that the source is available to you, it's probably going to be faster to just buy the thing. Or maybe if it's a tube but it has some special features, maybe you buy the tube and then print only the special features and slide them or glue them onto the tube. All right, so that's number 1 thing, is you don't have to print everything. Number 2 is know the different materials you have available. I picked some of the more common materials. I didn't put ASA on here, although it is probably more common now than ABS. So it started out, when we'll go through a history lesson at some point, but when we started with the home printers, so 15-ish years ago or so, maybe a little more than that, a patent had just not worn out, but expired, and it suddenly was possible for people to put together kits of printers, or at least printer parts, and you could then build one at your house. But there was no filament other than like Weed Eater line or ABS. ABS was the filament that was available. And so it was the main print material for a long time, or at least for quite a while. The downsides to it is that it warps really badly in these printers that are open air, so they're not enclosed. It is kind of smelly when it prints, a little bit noxious to people if they're sitting near the printer. So it has some pretty strong downsides, and it's not as popular anymore. PLA is by far the most popular thing. I wonder if I can make this larger. Yeah, I can make this larger. All right. So PLA is the most popular one, but it's going to be a little bit brittle, hard to finish, so sand and polish, stuff like that. And so it's not great for functional prints because it will get probably a little too brittle. PETG is usually the one that I go to when I want to print a functional part. So I've got like 2 or 3 rolls of PETG sitting over here, and that's usually the one that I go to if I want a functional part. It's strong, maybe not like as its ultimate strength is not quite that of PLA, but it's still strong, and it's more tough, so it's a little bit more flexible. It's not like rubbery, but it is more flexible. It does have the downside of it can get stringy because you have to cool it less if you want this strong part, but it's a good material to work with. TPU is just, you want a different thing. So TPU, let's see, I have some somewhere. Let me see if I can. Here's some TPU. See, it's like a rubber band kind of filament, and so you can print flexible rubbery parts on the Ender 3. You have to print really slowly usually, but you can print this kind of material. So it's for something where you need impact strength, or you need the flexibility, or you need that rubberiness. Nylon is a good material. It is a flexible material, but usually nylon that you print has some other thing in it, like carbon fiber chopped up in, well, not chopped up, but ground up in it. So it has little carbon fiber particles to make it stronger. It is a little bit hard to print because of the temperatures involved. And so usually you're not printing that on just a regular printer like we've got here. But we'll try to print some nylon on here and just, see how well it comes out. It should be doable, but it's a little bit risky. I'm looking at our print here to see if it's going to stop. I hope I load, yeah, I did save the right file, but so far it's just carrying on and hasn't stopped on me, so we'll let it go a little bit longer. So this nylon we won't use often. Most of the time I'm going to go with PETG because it's a little bit higher glass transition temperature, so it can withstand heat a little more, and there are a lot of PETGs that have carbon fiber and glass fibers and other fibers in them that strengthen them up. I didn't list ASA because I haven't printed with it a lot, but it is kind of an in-between ABS and PLA kind of material, and I just haven't had enough experience with it. I've heard that it's a really good material to use, but I've also heard that it is a little bit obnoxious and you have to ventilate the fumes out. So that'd be fine if you were out in a shop or something, but if you're printing in an enclosed space, it may not be a good one, just like ABS. So know your options for materials. There are a lot of other materials too, but these are the big ones. So on your slicer, temperature in general, if you just print hotter, then it's going to be stronger because the different layers are hotter for longer and they just weld together better. Usually how printed parts fail is layer adhesion, interlayer adhesion. So one layer not sticking to the layer next to it, or that layer to layer contact failing somehow in like a shear failure. So if you just print hotter, then those layers are bonded together better. So that's one way to get a stronger part. Make sure that the bed is level. That's just to make a successful print, Extrusion multiplier. So this is another way to get more contact between adjacent strands of filament. So it's similar to the temperature idea that if it's just printed hotter, then everything melts together better. But here you're actually putting out more filament than is needed from the nozzle. And if you have more of it adjacent, then there's more of it to bond together. This is sometimes called flow rate. So that's another way that just not changing anything other than you just extrude more filament than you need, then it could be a stronger part. It may not look as nice because you've kind of over extruded, so it might be a little lumpy, and fine details might be lost, but it will bond together better because there's more of it. Try to minimize anywhere you need supports. If you have to have supports, then you can build in exactly what you need for supports in your model. But it's best if you can just minimize that, because the point where the support is holding up the part, that could introduce a weak spot because there's a little bit of a sag there or something. So it's just going to be a weakness in your part. So if you can get away with not having supports, or at least minimizing them, then that will be a stronger part. Be aware of how small can your printer print. So some of the calibration prints early on Canvas are kind of this type of thing, and there are others that I didn't assign for you to have to print one. But there's only so small of a part that you can actually print, and if you want strength, you want at least 2 walls of a part. So that's going to be generally 2 nozzle diameters. So it's going to be hard for you to print something that's strong and it's thinner than 2 nozzle diameters. So for our printer, that's 0.8 millimeters would be the kind of the smallest feature size I'd want to try and deal with. But that's what we're up against here. Make sure your first layer adhesion is good. That kind of relates over here to your bed leveling. But here I'm talking about the different temperatures that the bed is at. So I wrote down for, I put ABS in here just to point out that it might be difficult to print some of the stronger materials because they need such high temperatures on the nozzle and the bed. Like the Ender 3, 100 degrees Celsius, its bed can't get to that temperature without enclosing it and changing its firmware. I think there's a firmware limit on how hot you can ask for it to be. So be aware of the bed temperature. PETG, I usually print at 80, which the Ender 3 can do fine. And PLA, I usually print at 50, which is fine, although you can print it at 0. Well, not 0. You don't freeze it. It's just, it doesn't have to be heated. So I guess it's more like 20 something. Oh, there was our beep on our printer. All right. So it beeped. That was the warning that, hey, I'm ready. And it moved over to this corner. And I didn't tell it to change temperature, so it's just sitting there. So you wouldn't want to leave it too long, but it's not at least over our print. You can kind of see there's the base of that. So I'm going to do my filament change here. And we're going to put our red filament in. Remember, it's on our little make do spool here. This one has a little blobby end. I'm going to cut that off. I usually cut the end off anyway, but this one I definitely am. I'm hoping that this red is PLA. It was on a loose spool and it wasn't labeled, so if we notice it's not printing, then maybe it's not PLA. But I'm pretty sure it is. Oh, it's brittle. So it's been sitting out, and look at it, kind of brittle there. So whenever PLA snaps like this, that's because it's absorbed a lot of moisture and it's a little bit brittle. So apparently I need to be a little more careful with it. It may also give us a little bit of printing problems. If we hear it popping, kind of like Rice Krispies do when you put milk on them, then that's actual moisture, water in the filament that is boiling off and popping. It's okay, but it will probably leave a bad surface finish. I'm still getting blue, so let's try to push a little more red through there. Now I've got red. I'm going to load new and click. Now it's going to it extruded a tiny bit more, and it may not be perfectly red. I'm going to go with it. Click to restart. It lowers down, and then it picks up on the G code where it left off, and it's going to go back and continue printing. Well, again, I don't know if this red is actually PLA, but I assume it is. But some materials don't stick to one another. Like PETG and PLA don't actually stick very well to one another. So you can use that to your advantage. Use one as a support for the other one if you have two different nozzles to work with. But here, hopefully these are both PLA. I know the blue is PLA, and I assume the red is, and hopefully they stick together pretty well and bond together. So we will go back over here and finish out our talk, and then this should finish up by then, I think, or at least be close. Here's that idea again. Not everything has to be 3D printed. We're going to go specifically through some of these later. We don't have time today, but you can actually put metal plates or nuts and bolts or hardware. You can embed that in the print, just like we did here, where we paused the print in order to change filament. You can pause the print to put in hardware and then let the print finish around that hardware and encase it. There are also heat set inserts. So let me see if I can find a picture. I don't have one handy, so let's go to Amazon and just look for a heat set insert. Let's find a good. All right, so here's some. So these are not specific to 3D printing, but they are little brass, usually brass, threaded pieces of metal with these ridges on them, And what you do is you print a hole that's slightly smaller than these ridges, and then you use something like a soldering iron. Now there are more professional tools, but a soldering iron will work. And you heat up the insert and just push it into the hole, and now you've got melded into the print. This is after you finish printing. Melded into the print, you've got metal threads in there. So, and these are not terribly expensive. I got 400 of them for $15. And that's an assortment of M2s through M6s. So that's a thing you can do. We'll demonstrate that. I do have some. I just don't have any sitting here at the desk. Don't print tubes. Get PVC pipes. Don't print boxes. Get a project box from Amazon, or if there were still a Radio Shack, from Radio Shack. So if there's standard parts, just use standard parts and use your printing to supplement them. Don't think you have to print a tube or print a box. The orientation itself, the direction you create the print, actually affects the strength. Let's go over here to Shura, since we're done with this guy. Let's get him off of there, and let's put in a cylinder. So let's see. So let's say that I need to print, you know, again, I just said don't print tubes and cylinders and stuff like that, but here's one. For some reason I do need to print this one. If I print it this direction, you know, slice it. I made it be, should have, there we go. Then when I preview it, all these layers are stacked on top of one another, right? It's super easy, even if I made this solid, it's super easy for one layer to delaminate from the previous layer. So this is not a very strong part if it has to do anything other than like compression. But if I need this to act more like a pin of some sort, then it would be better, you know, to print it laying down. Oh, I can't get it on the table. There we go. So print it laying down. And well, right now it's showing printing it in halves. You could do that and glue it together, or you could, you know, drop it on the table. It'll have maybe some bad surfaces. Those red lines there are showing where it thinks it needs support material. I did not turn on support material, but you know, this direction, when I look at a cross section, I've got these really long fibers, and I could add more walls if I wanted to, but I've got these long fibers that would resist bending a lot better than the short, you know, the stacked layers on top of one another. So the orientation of a part actually matters on the strength of the part. So think about how it's going to be used and try to orient your layers so that you have maximum layer adhesion in the directions, or you have long fibers in the directions that you're going to need strength. Layer height. In general, thicker layers, if you think about it, and I haven't actually done the research, so this is a good little project. If one of the things you want to do at the end, or you have to do at the end of the course, is you have to do a little technical memo brief. One thing you could test out is, are thicker layers actually stronger than thinner layers? So the idea would be that if I have thicker layers, I have fewer junctions between layers, so there's fewer chances for failure. If I have thinner layers, then there's a whole bunch of layers in there, and I have more chances for something to go wrong. So it's sort of like a size factor if you've gotten to that in a upper level mechanical strength of materials course. But I haven't tested that. Just the idea is that thicker layers should be stronger, just on the probability of having fewer problems. Infill. Higher infill percentages do increase strength, but a lot of times the infill is not really connected together, so you might have to increase the infill line width if you want to take advantage of this. So that's over here. Let's see. If we look at, I think, oh, let's do line width, or just line. So here's the typed in line. Here's the infill line width. By default, it's set to your nozzle diameter, but maybe you bump that up so that it actually makes a thicker infill, and it'll have a little more strength. So you could just increase infill. Generally above like 60 or 70% doesn't really add much anyway. It doesn't seem like it, kind of tapers off the benefit of it if you try to just keep making a more dense infill. Wall thickness and the number of walls, our print just finished, and it looks pretty good. The wall thickness and number of walls will definitely add strength. In fact, that's usually what I do. And I will bump the infill to maybe 30%, but what I'll really do is I'll make it 4 walls, 4 perimeters, if I want a functional part that's going to have a lot of strength to it. You can also change to thicker walls, just like we did over here. There's wall line. You can make the wall lines thicker. The only problem with doing that is you'll lose some of your surface detail if you need it. You can add top and bottom layers. I usually go with 2 bottom and 3 top, or 3 bottom and 3 top, something like that. But you can just add more layers that are solid layers. So there's a blend of what material are you using, understanding the mechanical properties, the stress and strain and the shear planes that you have to deal with when the part is being used. Some practical experience of just how you can orient parts, or what material is going to be good in a certain environment. And you can get functional parts from 3D prints off of a printer like this. Let's check out our multicolor print. That looks pretty good. Let's see if we can get it off of there. I don't know where my scraper went. What did I do with it? Here it is. So let's get our purge line off. I don't like leaving those on there. There's our skirt. I didn't even look at it. Normally I watch the skirt go down to make sure that the print has a good chance of succeeding, but I didn't even look at that one that time. Let's see if we can get this off of here. So this is one way to get it off, right? Another way is to take the bed and flex it. Obviously now I've got more fingerprints and everything on the bed, so I really need to clean it. There, it comes off of there. If you've got a print that it's just stuck on and it's not coming off, let it cool, and you might even put the whole thing, in the freezer for 10 minutes, and then the build plate will usually cool at a different rate from your print, and they'll separate and they'll just slide off of there. This one came off with just a little flexing. I got to put my spring clips back on because I want the bed to stay on, or the print surface to stay on. I'm going to go ahead and clean it, because just so I don't forget that I touched it a bunch and start a print and it not stick very well. So I'm going to go ahead and wipe it down to try and avoid that problem in the future. Okay, so that looks good. Here's our little print. I mean, that looks good, and they're stuck together. They're basically one part. They're not going to come apart there. Got a few little strings here and there. There's one that I peeled out. If you've got strings that are really wispy kind of strings, a hair dryer on high, or if you have a heat gun, or a lighter or something like that, if you just wave it over it, it will melt those wispy strings, and you won't have to deal with them at all. Like there's one right there. You can't even see it. Maybe you can see it on camera, but there's one right there. I could just hit that with a hair dryer and it would go away. If there's just one, it's easy enough to peel it off of there. But if there's a bunch of them, then you might want to have a faster process. So, I mean, that came out pretty good. So that is a way that you can make name tags, you can make logos, you can make a variety of 2-color prints. Now you do have the issue of what you're really doing is stacking multiple colors on top of one another. They're not mixing in any way. So you do have to be aware that that's what it's going to do. It's going to print colors on top of colors. But if that's okay with you, then you can design your parts that way. You can do what we did, where you found the picture and then you took it to Photopea and turned it into a vector image, took that into Tinkercad and turned it into CAD geometry, and did the process there to make the little blue part lower than the red part so that you could print them separately. We have our code here. You can just take this code, drop it into your G code in something like Notepad, and you can do that over and over. You want to have 3 colors, you can add another one of these sections at the other layer that you want to change colors at. Oh, I got some questions. Let's see. When you go to do a print that has a skirt, also diff purge line, yes. Oh, it does a purge line that tends to start from the center of the plate. Oh wow, that's weird. I assume the center. Oh, yeah, you're right. It's probably that it just homes in the center. I think your particular printer has a bed sensor on it, and so they do home in the center, and so it probably is just a purge, not a purge. It's just oozing. So, some things you can do to deal with that are, I don't have them here, but I normally have some tweezers that I go and I grab the, I'm showing you stuff that you can't see. I go and grab the filament that's hanging off the bottom of the nozzle with those tweezers, and I pull it off of there right before it tries to do any kind of movement, because it will do that. But I think what you're talking about there isn't the purge line. It's just oozing because your bed homes in the center. This printer doesn't have a bed sensor, so it homes over in the corner, so the ooze doesn't, and it does the purge line right up the side, so the ooze becomes part of the purge line. But yes, if you have a printer that homes in the center, like a lot of the ones with a sensor, it'll home right here, and then it goes over here to do a purge line. It's just dragging and oozing filament the whole way. And what I do is I just grab it with some tweezers and peel it off of there before it becomes part of the print. Because the only other way to deal with that is you could like manually retract the filament that's in here, like, you know, pull some of it out so that it's not in the nozzle to ooze to begin with. So you could do that and then let the purge line, you know, be the part where it starts the ooze and the purge. So you could do that if it annoys you, but in general what I do is I just well, my printer currently does not have that problem because it doesn't have a sensor and it homes in the corner. So once we get a sensor on here and it homes in the center, then I just use some tweezers and grab it. It's hot, so that's why I use tweezers. I'll show you the ones I have once I get them out. I don't need them right now, so I haven't gotten them out. You can sometimes use like these to grab it. You just have to be careful you don't actually grab the nozzle and put a burr on your nozzle. All right, so let's see what we've got next time. Next time we should be on Wednesday. We should be live, and it should be some. Oh, all right. So we're gonna. Looks like we're gonna change the print bed. Maybe talk about some lightweight PLA, which is a kind of different material. I need to find some of that. We may have to postpone the lightweight PLA because I may not have any right now. Assuming I can find some, we will do that. Otherwise, we'll talk about Mesh Mixer, which is a cool piece of software for creating new stuff that you may not have thought of before. All right, I will see y'all Monday.